Hey guys, hopefully everything has been going well. Again, remember to reach out to me if you've got any questions or concerns. But here we're going to get looking at the last section of chapter 10, which is looking at writing equations of circles, writing and then graphing circles. So what we're looking at first of all is the standard form of a circle. So we've seen what various equations, what kind of graphs they form. The one that we really talked about so far is y equals mx plus b, and hopefully you remember that forms a line. So it's basically the combination of x coordinates and y coordinates that work in that equation, and if you plot those points, they form a line. Here we're looking at the standard form of a circle, x, and this is what it is, x minus h squared plus y minus k squared equals the radius squared. And then the h and the k represent the center. So when you're looking at this, the h and the k are going to tell you the center of your circle, or when you're plugging in, you're going to put the x coordinate of the center and the y coordinate of the center in for the h and then the k, and then the r represents the radius. And I want you guys to look at this for just a second and see if it looks familiar, see if it kind of reminds you of something. Hopefully as you're looking at this, it reminds you of one of two things which are related that we've talked about before. You may think it looks kind of like the Pythagorean theorem, something squared plus something squared equals something squared, or it might look familiar, look very similar to the distance formula, and that's actually not a coincidence. All of those things are interrelated. So if you think back to what the definition of a circle is, we talked about in the very first section, it's the set of all points that are a fixed distance away from the center. So that distance is always that radius, and so the equation looks a lot like the distance formula, which the distance formula comes from Pythagorean theorem. Basically, the radius is representing that hypotenuse there. So there's that similarity here. And so we're going to go ahead and start looking at some examples of how we can use this formula. First thing we're going to do is write some equations of circles. All right, so here we want to write the equation of a circle. First, we need to find the center. And looking at this picture, we can see that the center of this circle is right there at 0, 0. Then we need to figure out what the radius is, and that's 3. So now we can plug that into the formula. It's x minus the x coordinate of your center, so 0 squared, plus y minus the y coordinate of your center, which is 0. And then it's equal to the radius squared, which is 3 squared. And then we just have to simplify this down a little bit, and then we have our answer. So you can't always simplify this part down, but in this case, x minus 0, when you subtract 0, it doesn't actually change anything, so that's just going to be the same thing as x squared. Same thing here. That's the same thing as just y squared. And then we know what 3 squared is. That's 9. And that is the equation of this circle. Okay, so now we have one where the center is not on 0, 0, but the same process. It's going to be x minus 0 squared plus y minus negative 9 squared equals 4.2 squared. So again, we can see x minus 0 is just x, so that's x squared. Here I can't simplify this down any further as far as to where I can get rid of the parentheses, but I can go ahead and change this from from y minus a negative 9 to being y plus 9. And then I just need to figure out what 4.2 squared is. So let me get my calculator out. You guys can too. 4.2 squared is 17.64. And that's our equation. All right, once again, here we've got the equation of the circle. We're told that the point -5, 6 is on the circle, and the center is -1, 3. So if we start trying to write the equation like we've been doing, x minus, this is our center, so make sure you don't get confused with the 2 points here. Make sure you use the center, so -1 squared plus y minus 3 squared equals the radius squared. The only problem here is that I don't know the radius. Okay, in the last two examples, well, the last example, we were given the radius. The example before it, we had the graph and we could look and count the boxes to figure out what the radius was. But this we're not. Instead, what we're given is we're given a point on the circle. And we know that the radius is simply the length of the segment from the center to a point on the circle. So all we have to do is find the distance. So I want to find the distance between those 2 points. That's going to be my radius. So that's going to be so we're using that distance formula. The square root of x minus x squared plus y minus y squared. Again, you'll notice it's pretty much our standard form of a circle, just with, instead of it being equal to r squared, you've square rooted the other side, because again, there's that relationship between the distance formula and circles. 3 minus 6 squared. -1 plus 5 is 4. 4 squared is 16. 3 minus 6 is -3. -3 squared is 9. So that's the square root of 25, which is 5. So now we know our radius, and our equation is going to be, I'm going to go ahead, as I write this, I'm going to go ahead and change that from minus and -1 to x plus 1 squared plus y minus 3 squared equals the radius squared, which now I know the radius is 5, so that's 5 squared, so 25. All right, last thing we're going to look at before we try some examples on your own is how do we graph a circle? So the last couple examples, you were given either points on the graph, you were given the radius, you were given the center, and you're trying to write the equation. But now we're going to be given the equation, we want to draw the circle. So in order to draw the circle, the two things that we need to know is where the center's at and what the radius is. So I'm going to go back for just a second and notice how when we were writing, oops, I didn't go back, sorry. Notice how when we were writing the equation, we used the center in here. So if you look at our three examples, the numbers with the x and with the y came from our center. So if we look at this, we can look at the number with our x and the number with our y to help us figure out our center. But I want to point something out. Because it was x minus h and y minus k, I want you to look back at those examples that we did first of all and look at, with the actual equation, how those numbers compared to the center. And you'll notice in all cases, the sign is actually flipped for both the x and the y. So this is x plus 2, but the center was at, x plus 1, but the center was at -1 because we were subtracting. And so looking at our example, oops, sorry, I went too far. Looking at our example here, the center, it's got to be the opposite sign of this, so it's going to be a +4 and a -2. So I'm going to go +4, -2. And then we need to look here for our radius. And if you remember the formula equals the radius squared. So here we have 36, but that's not the radius. That's the radius squared. So to find the radius, we have to square root 36, which is 6. And so from here, from our center point, we want to go 6 units to the left. 1, 2, 3, 4, 5, 6. 6 units up, and when we always go back to that center point. 1, 2, 3, 4, 5, 6. 6 units over. 1, 2, 3, 4, 5, 6. I didn't make my graph big enough. Sorry about that. And then 6 down. 1, 2, 3, 4, 5, 6. And I can't go 6 diagonal because I don't have grid boxes. But these 4 are enough to give me an idea of what this circle should look like. Your circles don't have to be perfect. Just make sure that you've drawn them as a circle. If if it's not a perfect circle, that's okay. Granted, if you just draw straight lines connecting those 4 points, then that is not a circle at all. So just make sure that you're at least trying to make it circular. All right, so now we just have a couple more examples of practicing those. So let's go ahead and look at those. The rest of the examples are just practicing those same skills. So feel free to go ahead and try each of these on your own, and then you can just go back and check yourself. Or if you're still unsure about things, feel free to kind of follow along a little bit more with the video. All right, so here again we're writing the standard form of a circle. It's going to be x minus 0 squared plus y minus 0 squared equals 2.5 squared. So we're going to look at how we can simplify that down, and it's going to be x squared plus y squared, and then 2.5 squared is 6.25. Okay, again, writing the standard form equation. That's going to be x minus negative 2 squared plus y minus 5 squared equals 7 squared. And so that gives us x plus 2 squared plus y minus 5 squared equals 49. Alright, again, find the center right off the bat. X minus 1 squared plus y minus 4 squared. This time we don't have the radius, so we're going to have to use that distance formula to find it. So 3 minus 1 squared plus 4 minus 4 squared. 3 minus 1 is 2. 2 squared is 4. 4 minus 4 is 0. 0 squared is 0. Square root of 4, which is 2. So we get our equation to be x minus 1 squared plus y minus 4 squared equals 2 squared, which is 4. Alright, another one, same like as the last. Find your center. And then we have to figure out what our radius is by using the distance formula. Negative 1 minus 2 squared plus 2 minus 6 squared. That gives us negative 3 squared, which is 9. And that's negative 4 squared, which is 16. And we get the square root of 25, which is 5. So we get x minus 2 squared plus y minus 6 squared equals 25. Alright, last one, graphing the circle. So again, we have to start with our center. And remember that it's going to switch the signs. So it's negative 2, positive 1. This one, that's our radius squared, so our radius is going to be the square root of 4, which is 2. So 2 in each direction. And then draw your circle. And that is it.